Okay, good morning, students. Yesterday, I was trying to take a class, but unfortunately, it was not uploaded. I am continuing the chapter Carbohydrates, in which we are discussing the different structures of glucose and fructose before going to disaccharides. As you know, glucose and fructose molecules combine together to form a sucrose molecule. One glucose molecule and one fructose molecule. And the fructose and glucose molecules, in both the molecules, the molecular formula is C6H12O6. So, same type of molecules, glucose and fructose, they are combining together to form a sucrose molecule by removal of carbon molecule. That we will discuss later in case of disaccharides. But today, as you know, the structure of glucose, you have three types of structure of glucose. One is open chain glucose, a ring structure of glucose, and then the Howard structure of glucose, which we discussed in the last classes before 2 to 3 weeks. Today, let us see once again the open chain ring structure and the Howard structures. Let me show you the camera to the nearer angle. So, this is the glucose molecule, glucose open chain molecule. Okay, this is the ring structure of glucose molecule. Ring structure, you can see the number 1, this is the anomeric carbon atom, and number 5, this carbon atom. So they are joining together with the help of an oxygen molecule. That means you one hydrogen atom from the open chain, 5th carbon atom moved to the oxygen atom. Okay, 5th, you can see this carbon atom 1, 2, 3, 4, 5. Here it was OH group, but this hydrogen atom is moved to the top. Here it is there, H in the left side and OH is on the right side. And here it is, H is formed a ring between to the CH is formed a ring between CHOH like this. And this bond is known as glycosidic bond. Glycosidic bond is a bond in between C1 and C5 through the oxygen atom. So this is the ring structure of the compound. And we have to write, of course, let me fix the camera once again. The Howard structure. Howard structure is you have to write the Howard structure is based on this ring structure. So you have to write by seeing this, which you have written here, which I will show you later. But I will tell you how to write the Howard structure of glucose. So oxygen atom, this oxygen atom we have to put here, and as you know the bonds you have to put like this. And now the left side groups you have to write the top, that is HOH. The other side group, right side group, you have to write the down. Again left side group HOH. Then here it is OH. This is HOH. Understood? The left side group you have to write the top of the bond, and the right side bond you have to, the right side group you have to down. You have to write it down. And here, starting from top, you have to write HOH, right? HOH again, OH, HOH, and the last group you have to reverse HCH2. So this is the ring structure. Ring structure means this is one of the structures of glucose. This is alpha D plus glucose. Alpha D plus glucose, because the OH group is here, it is placed on right side. If it is on the right side, that is alpha. If it is placed on the left side, that is beta. I told you in class. D plus is actually it is a representation. D plus nothing but in D plus is dextro is based on the carbon number 2 from the bottom. Where the OH group is placed on the right side, then it is known as D. And plus means the compound is dextrorotated. The compound is dextrorotated. So this compound is nothing but it is a D plus means the right side of carbon number 2 from the bottom is on the right side. The meaning of that. And alpha means the top, at the top the OH group is placed on the right side. And plus means it is a dextrorotated compound. So this is the structure of the ring structure of alpha D plus glucose. Correspondingly, this is the structure of Haworth structure. This is known as Haworth structure. Haworth structure. You can write Haworth structures for any carbohydrates. I will show you again the camera very near to the blackboard for the convenience of the students. See, already I have written here the alpha D plus glucopyranose and this is the beta. Same thing now I have written here. This compound and this compound both are same. So this is alpha D plus glucopyranose and I will tell you what is pyranose. And this compound is beta. Beta is nothing but the OH group. If suppose it is left group, left side one, then that will be beta D plus glucopyranose. Okay, let it be. And here, this compound I will write down. This is alpha D plus glucopyranose. Pyranose. Pyranose. Because it is a 6-number ring system which is related to the compound pyran. Pyran is a heterocyclic compound. If it is a 6-number ring system, it is related to the parental compound pyran. Therefore, it is a pyranose. Alpha D plus glucopyranose, because this compound is related to the parental compound, that is pyran. Similarly, beta also. Please check the beta structure. I will have already written. That is the only change. Change will be happening here only. If you write OH here, this compound, and this here. And here there is a change, that is OH will come here and H will come. That I told you the left side group should come. So then correspondingly this compound will be beta D plus glucopyranose. So alpha D plus and beta D plus. Students, you must know that the open chain structure is a single structure. Correspondingly you have to write two structures, alpha D plus alpha structure and beta structure according to the reactions shown by the open chain structure. Majority of the reactions will be satisfied by taking the open chain structure. But some properties like Mutter rotation and some properties, some of the additional reactions which will not be satisfied by taking the open chain, which cannot be explained also. Which cannot be explained by taking the open chain structure. So therefore we have to move to the ring structure. There are two types of ring structure, alpha and beta. Those historical parts I already discussed with you in the previous classes. Why we have to select a ring structure. And there is one thing pending still now. Why we are taking this as this ring structure? That we will discuss in the next class. Right? So here the open chain, then a ring structure. Ring structure there will be two structures. One is alpha D plus glucose and beta D plus glucose. And for both you have to write the most important Haworth structures. So that I have written here. This structure is for the alpha D glucose and this is for this one is for beta. Both structures are written for beta D glucopyranose. What is pyranose? Pyranose is a structure 6-number ring system, which it is, the name is connected to the parental compound, that is pyran. Right? So that is about the glucose for the time being. There is one more very important issue to be solved. That will be, we are waiting for the Jan for that, maybe in the next class. And next we have to go for the fructose molecule. Fructose is, I told you, fructose and glucose, the molecular formula is same. So this is the fructose molecule. This is the fructose molecule, in which you can see there is a CO group here. Second carbon atom, there is a CO group. That is the first. This structure is nothing but it is the open chain structure of fructose. And for this you have to write the closed chain. That is the ring structure of fructose. A ring structure of fructose actually happened here only. I will tell you. I will explain now. So this is the open chain structure of fructose, right? Open chain, and the second one is the ring structure of fructose. And let us go for that. How we get the ring structure of fructose? Let me, I'll put like this. Okay. So fructose molecule, I am rubbing it off regarding glucose. Let us go to fructose now. And fructose also, okay. The first one is fructose molecule, and I will write now for your convenience. CH2OH, okay, CO, CH, C, 1, 2, 3, 4, 5, 6, CH2. Here it is CHOH, and here it is also CHOH. And the formula is almost same. OH. Configuration is almost same for both. CH2OH, CHOH, CHOH, COH, CO, CH2OH. And this bottom I told you in the previous times that if OH group is come on the right side, then that will be a D structure. It will be a D structure. Let it be. Let us go to the next part. So this is the open chain structure of glucose. C6, okay, H6, H12, O6. Okay, so this is what it is. This is the open chain. And you have to write the closed chain also, that you have written there also. How you have to write it? You have to take the second carbon atom. And here you have to write the CH2OH group, that is this group. And here you have to write this oxygen, along with oxygen, one hydrogen atom. Let us go to the pyramidal structure, 6-member system, that is from here. It is CH2OH you written here. Okay. There was oxygen here. To this oxygen, this hydrogen atom, last hydrogen atom. So here we see OH, H, CH, OH, and CH, OH. This is CH2 because this hydrogen atom is gone to here, and there is a glycoside, there is a ring structure. Ring is formed like this. So this is the ring structure of fructose. Ring structure. This one is the open chain structure, and this one is the ring structure. You can see the molecular formula is C6H12O6. And now I have written the ring structure according to the Pyranus form. Pyranus form ring structure is like this. Yesterday also I tried to write it, but it was not recorded properly. So this is the ring structure. This ring structure of fructose you have to write according to a Pyranus system, that is Avarta structure. So a 6-member ring system, this oxygen you have to put like this, and you have to write put the bonds. And left side group you have to write, this is OH group is on the right side, that is CH2OH, and this one OH, and this one is OH, and this one is HOH. Again there is one HOH. And finally CH2, that this is C and this is H2H. So this is the, what is this? This is the D plus fructose Pyranus. And moreover this is alpha. This is because OH group is on the right side. Alpha D plus fructopyranose. Similarly, you can write beta D plus fructopyranose also. If suppose here the groups are interchanged, this carbon atom in this case it is known as anomeric carbon atom. So it is, if your groups are interchanged, so OH comes here and OH will go there. So this is alpha D plus fructopyranose. Similarly, you can write beta D also. Beta D is suppose only the change is here only. And here only. Beta D the change is here only. This OH is here and CH2 OH. If you put like this, the OH here and CH2 OH is here. Naturally, it will become beta D plus fructopyranose. But in the case of fructose, it is a part of the sucrose molecule I told you already. It is a part of sucrose molecule. And the sucrose molecule, one glucose molecule is fused with one fructose molecule. But glucose molecule is in the pyranose form, 6-member ring system. And fructose molecule is in the form of a 5-member ring system. Therefore, you have to study both, that is pyranose form as well as the furanose form. What is furanose form? Furanose form is a 5-member ring system because if the parental component is a 5-member ring system, that is not furan, the heterocyclic compound. Right. So therefore, you have to change this ring system into a 5-member ring system, in which this is exempted and this one. This I have written here again. Now there is no use for this open chain. You write the 5-member ring system. This is actually the ring compound. That is the ring compound means this is the 6-member ring system. If I suppose I have to change into a 5-member alpha form, it will be CH2OH, it will be OH here, and it will be COHH, and it will be CHOH. Again, it will be CH, and the ring is formed here. Okay, it will be like this, and here is CH2OH. Written here. You count them 1, 2, 3, 4, 5. 5-member ring system. The hydrogen atom here is transferred into here, and there is a ring formed between carbon number 2 and carbon number 5. C2. You have to leave it. 1, 2, 3, 4, 5. 5-member ring system. How you can write the Hammond structure for 5-member ring system? That is also very important. This is alpha form. This is alpha D. Okay, alpha D plus or minus that. This is not important because that is plus or minus is depending upon the optical power. Fructose. And what will be? Let us see this. This you can write like this, a 5-member ring system. That is, you have to write a pentagon. Okay, this is a pentagon and put one oxygen here and you have to put the bonds like this. And write the groups as accordingly. CH2OH at the top and OH down, and this is OH and H, and this is H and this is OH, and the last one H and CH2OH. This compound is nothing but you can name it as alpha D plus or minus whatever it may be. Fructose is depending upon the property of that. Sometimes it will become minus also. So that is in this I am writing here alpha D plus fructopyranose. Alpha D plus fructopyranose. Similarly, you can write beta D plus fructopyranose. Beta means OH you have right here, and CH2OH you have right to the right side. That means only the change will come here, occur here. Okay, I can show you how to write the beta D plus fructopyranose also. So, if you write the beta molecule, again you have to write one pentagon, and you have to put the bonds like this, and you change the group here. There's OH group here and CH2OH. And the remaining these all are same. There is OH, H, HOH, and here is H, CH2OH. This is nothing but this is the beta form, beta D plus or minus what will be glucofuranols. Sorry, fructofuranols. Oh, I will ask. Fructofuranols. This is the way of writing the how are the structures of the carbohydrates. And in examination there will be some 3 to 4 marks. Write the structure of sucrose. Write the structure of maltose. How are the structure of maltose? How are the structure of sucrose? Like that there will be questions. 3 marks per question. You may get. And fructose you should know, glucose you should know. Then you can use these two ring systems. Glucose ring system and the fructose, and sometimes two glucose ring system in the case of mannose, galactose, like that. You have to fuse the ring system to get the disaccharides structure. So now I wanted to say one more thing, that is you could understand what is furanols and pyranos. In the case of glucose only pyranose structures are there, alpha and beta. In the case of fructose, both pyranose form, that is 2 forms, and furanose forms, also 2 forms will be there. So you have to study all the 4 structures in the case of fructose. The structural study of fructose also will take in the next class. Structure of how to get the open chain and the ring structure of fructose molecule. That will be discussing in the next class. And this is about today's class. After long time, after I think there are 10 days or 15 days we are meeting again. And please touch with us. And there will be a new timetable is coming into effect from the next week. And according to that timetable we will take the classes. Thank you once again.